Okay, welcome to part 2 of prime factorization. So prime factorization, you all have been waiting. What exactly is it? Prime factorization is when you break down a number into its prime factors. Remember that prime numbers are primal. They're basic. They only have factors of 1 and itself, and that is it. So let's look at the prime factorization of 24. I have two methods I would like to show you. The first is an upside down division. So I'm going to write 24. Oops, it's kind of messy. And just like that. Okay, so I want to think about what number can go into 24. And we can start low or we can start high. I'm going to start low for right now. So I'm going to write the number 2. 2 goes into 24 12 times. And I'm going to work with 2 again. 2 goes into 12 6 times. 2 also goes into 6 3 times. Now look at my numbers out here. I have a 2, a 2, a 2, and a 3. These are all prime numbers. I have taken 24 down all the way to its prime numbers. So you will rewrite this as 2 times 2 times 2 times 3. But you're not done there, okay? So you all have learned about exponents. This is the same thing as 2 to the third times 3. And this is your answer. Now you may have learned this before. So this is method number 1. I call this upside down division. And then here's another method, our factor tree. This is where we have 24 at the top, and we are going to create a factor tree all the way down to its prime. So I'm going to do this one a little differently just to show you. You can start small with 2, or you can start larger with a larger factor. So why don't we start with 8 times 3 is 24. So I have 3 and 8. 3 is a prime number. I'm done with that one. That one's not going to go any lower, so I'm going to circle it. Whoa. Okay, sorry about that. And 8, I think I'm going to do 2 times 4. 2 is a prime number, so I'm going to circle this one. And I can still break down this 4 into a 2 and a 2. Okay, so I have a 2, a 2, a 2, and a 3. And it's going to be the same thing. I want your answer to look just like this one. Okay, and then you can double check yourself. You can go in reverse. You can think, okay, what is 2 cubed? 2 cubed is 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Okay, so you know you have the right answer. Let's find the prime factorization of 30, doing my first method. Okay, so I'm going to put 30 in an upside down division, and I'll start small. 2 goes into 30 15 times. Let's see. So now I need to think about what number can go into 15. So 3 goes into 15 5 times. And here I have all prime numbers. I have 2 times 3 times 5, and that is my answer. Let's do it as a factor tree. My second method. So I start with 30. Let's think a bigger number, okay? Because I'll be honest, if you start bigger, then you will be finished faster. So 3 times 10 is 30. 3 is a prime number. And now I need to break down my 10. 2 and a 5. Now that's as low as I can go because these are all prime numbers. Okay, so I have 2 times 3 times 5. And I like to write it in order of number from smallest to largest. I think it just makes sense. And it just seems more organized and neat. So I prefer you all to do the same. Let's find the prime factorization of 20. Oop, that's my first method is doing the upside down division. So let's start small. 2 goes into 20 10 times. 2 also goes into 10 5 times, and that is as far as I can go. Okay, so my final answer would be 2 squared times 5. That is it. Okay, second method, my factor tree, starting with 20. I'm going to do, let's change it up. 4 times 5. I can't go any further with my 5. That is a prime number. And my 4, 2 times 2. Okay, so I have 2 times 2 times 5. And remember, I want it written. If you have a prime number, if you have more than one prime number, you need to write it to its exponent, how many there are. Okay. One more example. First method, method 1, upside down division. So 36. Let's start small. 2 goes into 36 18 times. 2 goes into 18 9 times. So 2 can't go into 9, but 3 can go into 9. 3 goes into 9 3 times. So I have 2 times 2 times 3 times 3, and my final answer would be 2 squared times 3 squared, and box it. Okay, let's do it my factor tree way. 36. Okay, let's start with bigger numbers. So 6 times 6, and I have we know that 2 times 3 is 6, 2 times 3 is 6, so same thing, 2 times 2 times 3 times 3, and we get, this is how I want you to write your answer. Find the prime factorization of 315. So 315, and I'm going to do an upside down division, and because of the divisibility rules, I know that 2 can't go into 315 because it's not an even number and it doesn't end in 0. So let's add this and see if it's divisible by 3. So 5 plus 1 is 6 plus 3 is 9. It is divisible by 3. I'm going to start there. So 3 goes into 315 105 times. If you're not able to do that in your head, just do it over on the side. 1 plus 0 plus 5 is 6, so we know that 3 also goes into this. So 3 goes into 105 35 times, and let's take it down again. 3, actually 3 cannot go into 35 because 5 plus 3 is 8, and 3 does not go into 8 evenly. So let's go into 5. 5 goes into 35 7 times. My answer is 3 times 3 times 5 times 7. 3 squared times 5 times 7 is my answer. Now, if I wanted to do a factor tree, I would start up here, 315, and break it down to 63 times 5. Okay, starting a little bit bigger with my 5, and then 63 times, let's think, 9 times 7. 7 is a prime number. I'm going to circle that. And 9 can be broken down into 3 times 3, and I'm going to circle that. So here again I have 3 times 5 times 7. I like to write it in order. And this is the answer that I will be looking for. Okay, have fun with your homework. I'm here to answer any of your questions, and see you next class.